Hi students, in this video we will be solving an important possible question, a 5-marker question from Matrices chapter. In Karnataka PU board exam in part D, a 5-marker appears from Matrices chapter and this is one of the possible questions. In this video we will be solving a worked example and it is worked example 18. As I have told you in my earlier videos that even a worked example can appear in the question paper. It has already appeared many a times, so take it very seriously and solve all worked examples along with exercises. So the question goes like this: if A is a matrix which is like this, then show that A cube minus 23A minus 40I is equal to O. What is I here? I is identity matrix and O is the null matrix. Is this clear? Yes. Now we have to show that this whole thing is equal to a null matrix. When you are asked to do such sums, it is very easy for you to verify your sum. Why is it so? Because they have clearly asked you to show that this whole thing is equal to a null set. That means you know what you have to do, or you know what your answer should be. Whenever a sum is like prove that, show that, verify, something like this, then you clearly know what should your answer be. Whereas when they say evaluate, then you may not know the right answer. But in such questions, it is very clear that what your answer should be. So even if you go wrong somewhere, you can go back and correct yourself and get that full 5 marks. Is that clear? Yes. Now we shall consider matrix A and we have to find A cube. For that, let us find A square first. I am considering A into A. So A square will be, first I will be considering first row, then multiplying with the corresponding elements of the first, second and third column. Then we'll consider second row, then multiply with the first, second and third columns of the corresponding elements. Again consider third row, then multiply with the corresponding elements of the first, second and third column. Is this clear? Yes. So A square will be, now I am considering first row with first column, 1 into 1, 2 into 3, 6, 3 into 4, 12. So it is 1 plus 6 plus 12. Now first row, second column. Then it is 1 into 2, 2 into minus 2 which is minus 4. Then 3 into 2 is 6. So 2 minus 4 plus 6. Then first row, third column. 1 into 3, then 1 into 2 and 3 into 1. So it is 3 plus 2 plus 3. Now we are considering second row with first column. That is 3 into 1 minus 2 into 3, that is minus 6. Then 1 into 4 is 4. So it is 3 minus 6 plus 4. Now second row, second column. Then it is 3 into 2, 6, minus 2 into minus 2 plus 4. Then 1 into 2 is 2. So it is 6 plus 4 plus 2. Then second row, third column is what we are considering now. 3 into 3 is 9. Minus 2 into 1 is minus 2. 1 into 1 is 1. So 9 minus 2 plus 1. Now we are considering third row and first column. That is 4 into 1 is 4. Then 2 into 3 is 6. Then 1 into 4 is 4. Now third row with second column. 4 into 2 is 8. Then 2 into minus 2 is minus 4. 1 into 2 is 2. So it is 8 minus 4 plus 2. Then third row, third column. 4 into 3 is 12. Then 2 into 1 is 2. 1 into 1 is 1. So it is 12 plus 2 plus 1. So when we simplify this, we get A square. So if we simplify this, this is 19. Then on simplifying, you get this as 4. And this is 8. And this is 1. This is 12. This is 8. This is 14, 6 and 15 here. So this is our A square. Now we have to find A cube, right? So we'll consider A cube, which can be found by multiplying A to A square. So A into A square, or it can be A square into A. See, in general, we know that matrix multiplication is not commutative. But when they give such questions, you can multiply A into A square or A square into A. You get, here in this case, it will be commutative. So you can multiply that. So you get the same answer. After you have watched this video, you can also check multiplying a square into a, you will get the same matrix a cube. So I have written a here, then a square here. So we'll consider first row now. First row, first column. So a cube is 19 into 1, 19. 2 into 1 is 2. 3 into 14, 42. Now we are considering first row with second column. 1 into 4 is 4. 2 into 12 is 24. 3 into 6 is 18. So it is 4 plus 24 plus 18. Now first row with third column. So it is 1 into 8 is 8. 2 into 8 is 16. 3 into 15 is 45. So it is 8 plus 16 plus 45. Now second row with first column. That is 3 into 19 is 57. Minus 2 into 1 is minus 2. 1 into 14 is 14. So it is 57 minus 2 plus 14. Now second row with second column. So 3 into 4 is 12. Minus 2 into 12 is minus 24. 1 into 6 is plus 6. So that is 12 minus 24 plus 6. Now 3 into 8 is 24. Minus 2 into 8 is minus 16. Then 1 into 15 is plus 15. So it is 24 minus 16 plus 15. Now we are considering third row with first column. So 4 into 19 is 76. 2 into 1 is 2. Then 1 into 14 is 14. So it is 76 plus 2 plus 14. 4 into 4 is 16. 2 into 12 is 24. 1 into 6 is 6. So it is 16 plus 24 plus 6. Now second row and third column is what we are considering. 8 into 4 is 32. 2 into 8 is 16. 1 into 15 is 50. Now when we simplify this, we get this to be 63. We get this to be 46. And this one to be 69. And this one is 69 again. And this is minus 6. This is 23. This is 92. This is 46. And this is 63. So you do the simplification part. So we have now found a cube. Is there anything else that we have to find? Yes, we have to find 23a and 40i also. So this is the equation. I'm considering an identity matrix. We know I is an identity matrix, right? Yes. Identity matrix can be of the order 2 cross 2, 3 cross 3, 4 cross 4, 5 cross 5. It can be anything. But we have considered a 3 cross 3 identity matrix. Why is it so? It's because the matrix A is of the order 3 cross 3. So when we have to add or subtract, when we have to do something like that, we need to have a matrix of same order, right? So we considered a matrix of order 3 cross 3 only. Is this clear? Yes. So this is the identity matrix. How will identity matrix be? All the diagonal elements will be 1 and the other elements will be 0. That's all. So this is I. Now we have to find 40i. So that will be multiplying 40 to the matrix I. That gives us 40, 0, 40, 0, 40, 0, 0, 0, 40. That means in place of 1 we will have 40. That is 40 in the diagonal elements. So this is 40i. Now we have to get a null matrix. And what will its order be? We will again get a matrix of the order 3 cross 3 because a cube is a 3 cross 3 matrix. 23a will be a 3 cross 3 matrix. Why? Because A is 3 cross 3. So 23a will also be 3 cross 3. 40i is a 3 cross 3 matrix. So our null matrix O will also be a 3 cross 3 matrix. Is it clear? Yes. Now we already know A. So we are finding 23a. 23 into A. I have written matrix A. Now we'll multiply 23 to each of the element of the matrix. So it is 23 into 1 is 23. 23 into 2 is 46. 23 into 3 is 69. Then 23 into 3 is 69 again. 23 into minus 2 is minus 46. 23 into 1 is 23. 22 into 4 is 92. 23 into 2 is 46. 23 into 1 is 23. So this is 23a. Now we know all the terms of this equation. We are considering the LHS part of it and we'll prove it to be a null matrix. Okay, now LHS is A cube. A cube is what we have just found. I have written A cube here. Then minus 23A. We have also found 23A, that I have written here. Then minus 40I. 40I again is we have found here. So this is minus 40I. We have to add or simplify the corresponding elements of all three matrices here, which are of the order 3 cross 3. So we shall do it now. I'm carrying this term to the next slide also, so that it is easier for us to simplify. Now this is the term from the previous slide. We'll simplify the corresponding terms now. Now I'm considering the very first term, that is 63 minus 23 minus 40. You can see the sign here, both are minus here, negative signs. So it is 63 minus 23 minus 40. Now consider the second terms. It is 46 minus 46 minus 0. Correct? Yes. Now it is 69 minus 69 minus 0. It is so. Now you can see that only diagonal elements have this 40 as the term here. For all other terms, for the third matrix, it will be 0 only. Look at this. 0, 0, 0, 0, 0, 0. Clear? Yes. Now we'll consider the second row first element, that is 69 minus 69 minus 0. Now minus 6 minus of minus 46, which will be plus 46, then minus 40. So it is here. Then 23 minus 23 minus 0. Then 92 minus 92 minus 0. Then 46 minus 46 minus 0. Then 63 minus 23 minus 40. So when we simplify, we get this to be 0. Again 46 minus 46 is 0. 69 minus 69 is 0. 69 minus 69 is 0. 46 minus 46 is 0 again. 23 minus 23 is 0. 92 minus 92 is 0. 46 minus 46 is 0. 63 minus 63 is 0. So we have got a null matrix of order 3 cross 3. Is this clear? So when solving, if at all you go wrong somewhere, you can clearly make out from this step, or in this stage you can make out that you have gone wrong somewhere. Because if you don't get all the terms as 0 here, it is clear that somewhere something is wrong. You can always go back and check where things went wrong, and you can correct it and get your full 5 marks. Isn't it easy? Yes. So now this is O, which is null matrix, which is equal to RHS. So hence we have proved that A cube minus 23A minus 40I is equal to O. If you still have any doubt, please do mention it in the comment section.